All right, so today we're going to continue our percent mathematics by doing applications. You'll notice on your syllabus that the next thing due is the theme folder, but then the next math due is actually several sections. Chapter 5, review and test. Chapter 6, review and test. And then 6.2. 6.2 is percent of increase and decrease. What I want you to do, and then when we do have the percent test, anything from Chapter 5, I want you to do by hand. Everything from Chapter 6, I want you to do on a calculator. Okay? Because Chapter 6 is all business application. And so when you're dealing with business application, you're dealing with small and kind of odd percents, like 5.5%. You're also dealing with dollars and cents. So you can have, it's very messy computation. And the point in Chapter 6 is to be able to understand the use of the percent, not be able to do the messy decimal division. So when you do your Chapter 5 review and test for the next assignment, do them by hand. Do the multiplication and so forth. But anything from Chapter 6, anything that is a percent application, do it on a calculator. When we get to the test, there will be two sections. Top section where you have to show your work and actually do the percent math by hand, and then a bottom section where you're supposed to use a calculator. So anything referring to Chapter 6, do it with a calculator. Unless you want to torture yourself and do it all by hand, you can do that also. All right, so before you do Chapter 6, realize that all of Chapter 6 are calculator problems, okay? So let's go back through and review our 3 types of percent problems, and then we're going to start using them. Percents, of course, are probably the most useful, most applied part of arithmetic. All right, so we have 3 types of percent problems. We have our percent equation, the part or the percentage. We'll just use part equals the percent times the whole. Now we're going to be doing application. All right, 6.1 does not really involve any percents. Where we want to really begin is 6.2, percent of increase and decrease, which is a special application of this and requires a little bit of distinction between that. It's not the same as a straightforward percent. Then we're going to use interest. Interest involves a percent of the principal. And then we're going to do a few things with especially 6.6. I thought about assigning that separately, but I didn't. We'll just do the chapter review and chapter test for both Chapter 5 and Chapter 6. Wages is something that 6.6 that I want to talk about too. So let's go to 6.6 first, because it's a direct application of the percent equation. 6.6, we're dealing with wages. Wages involving commission and so forth. Commission is always a percentage of sales. So it's a direct application of our basic percent problems. So instead of having the part, this time the part is the commission earned. The commission earned is going to be equal to the rate of commission, which is a percent, times sales. So this is the first, probably the best way to start applying percents is to wages and salesmen who earn a commission, because commission is always going to be a percentage of a salesman's sales. So the commission earned will always be equal to the rate of commission times sales. And this is a direct application, and so we can start doing story problems with percents and so forth. Another direct application is interest. Not compound, we won't go there. Simple interest. is equal to the rate of interest, which is a percent, times the principal. It's not quite as direct as that one because we have to do what? Interest equals principal times the rate times the what? Time. So it does have an extra factor of time, and usually it's an annual interest, and so this time adds an extra little quirk to the interest formula. You probably remember from 6th grade, I equals PRT, another percent application. So let's take a look first of all then at 6.6, wages. This is a good way, like I said, it's exactly straightforward. This is a good way to start working with percent story problems for 6th graders and 7th graders in particular. Finding commission is easy because it's the easy part. It is the multiplication. So we want to start applying our percent problems to real life situations. And so when we do the commission problems, many times the story problems will have little quirks to it and so forth. The first part of 6.6 is just finding hourly wages, as in you make $20.15 an hour and you worked 8 hours, how much do you earn? But what we want to look at is on page 272, dealing with actual interest. Okay? And then with commission, you can see, here's an example on number 10. Carlos receives a commission of 12% of his weekly sales as a sales representative for a medical supply company. Find the commission he earned during a week in which his sales were $4,500. Well, what is his commission? There's our unknown. He earns 12% and his sales were $4,500. So then if we start with commission, we're starting with very easy problem, and students can figure out that, hey, this is not a big deal. So percent is best, the percent problems are best, the applications are best begun with commission. All right, and it's exactly applicable, and each part of it has its correspondence to the percent equation. So all we're going to actually do here is 0.12 times 4,500. Very simple application of what we've been working on. What has happened with 7th graders where they get into trouble is when the commission is given and they have to find the sales. Okay, and so this is an application of this part of the percent problem. And here's where we are certainly going to want to use our calculator. Let's say then that you can see on page 270 it says that an insurance agent earns $27,000 per year plus a 9% commission on sales over $50,000. During 1 year, the agent's sales totaled $175,000. Find the agent's total earnings for a year. We've got a lot of stuff going on there. But let's just do one of these when we're given the commission. Let's say the commission is $12.50, and the rate of commission is 1.5%. Find the sales. All right, so how much did this particular salesman sell if he earned $1,250? This is an application of the total problem. And so the easiest way to do this is algebraically, as we've been saying. This is 1.5, so it's going to be 0.15 times, we can use the letter S. So you can see the percent equation is going to tell me that the basic operation involved here is to simply divide this by, divide this 1250 by 0.015. Okay, so if we do the division, it's just a straightforward application of what we have been doing. So when we're teaching this in junior high and in 6th grade, we want to start with easy numbers and start progressing. And then another thing to make sure that we do is we will have to deal with this pesky decimal long division, moving this thing out. 15 goes into 125, what, 9 times? No, too big. 8. 120 goes into 50, 3 times, 45, and I'm going to keep getting 50. So then when I do this, I'm going to round to the nearest cent. And if we take a look at this, it kind of makes sense that in order for me to make $1,200, I have to sell either one large item or a whole bunch of little items. So commission and sales is one of the first applications. That's a direct application of being able to use what we know. That you try it problem on page 270, that will cause a lot of problems for 7th graders, won't it? Okay, so what should we do about it? Ignore it and not assign it, right? No, we need to try to get our students, the purpose of application is to get our students to think through a problem. Why do we want them to have math skills? So they can solve problems, not so they can get their diploma. So what we want to do is continuously, I'll use the word expose, continuously expose our students to application and go through the thought process with them. And don't give up on it, just keep going through it and keep going through it. So let's go through the You Try It number 3 on page 270. An insurance agent earns $27,000 per year plus a 9.5% commission in sales over $50,000. During 1 year, his sales totaled $175,000. Find his earnings for the year. So we have to teach our students to be problem solvers. And that's not going to happen unless we attack it. And this is going to especially be true in the junior high, but even in the 6th grade. We need to attack it head on and go through our own thought processes. One of the lectures that we did about long division. What do we want to do when we're teaching estimation? We want to show them our thought process. We want to vocalize our thought process, and we want to get them to take this story problem apart and figure it out and see that it's not that hard. When I read it all together, it looks very confusing. But what we need to do then is take it apart. So we need to organize our information, and we need to figure out this person's earnings. So we're going to start attacking our story problem, and we're going to try to teach our students to do the same thing. So we're going to organize our information. What do we know? We know first thing, just start at the very first sentence and work our way through. An insurance agent earns $27,000 automatically, right? A lot of times this will be referred to as their base pay. Plus he gets 95, or he's going to get his base pay. He gets this automatically. Then he earns a commission. So the overall problem that I'm going to do is I'm going to take his base pay plus his commission to get his total earnings. I'll deal with one thing at a time. So I want to take a step back and figure out, what am I trying to find? It says find the agent's total earnings for the year. I'm trying to find his total earnings. What are his total earnings in general? They're going to be his base salary plus his commission to get his total earnings. So then I can pull the commission problem out. What is his commission rate? It's 9.5%. How much did he sell? $175,000. But we have a little quirk. We have a little technicality, and that it has to be sales over 50 grand. Apparently, he's expected to automatically sell at least $50,000, and he gets commission after he's fulfilled that. So I guess the $50,000 is taken care of by the base pay. So I have to just take care of the little quirk. How much did he sell? He sold $125,000. So this is his extra sales that he gets his extra earnings for. So I'm just going to take things apart, and sometimes students have the habit of, if they can't see immediately what to do, they give up and go on. So what I need to do is just start writing things out and figuring it out. So then, what am I going to do? I'm going to change my percent to a decimal using my two places, and multiply not by 175, but by 95.095. Okay, so I think an easier way for me to do it is like this. I'm going to do it this way. I don't like all these zeros, do you? So I'm going to carry all the zeros down. 5 times 5 is 25. 47. And then keep in mind that these zeros are not part of that. 2 times 5 is 10. 190. And then 5, 9, 0, 0, 0, 5, 7, 18, 11. And then I've got my 3 places that are canceled out by that anyways, right? Because of this. So those two things cancel each other out, and my basic multiplication becomes that, doesn't it? Of course, you don't really want a 7th grader to do that maneuver, do you? All right, so there's my commission. So my total pay is $38,875. Not a big deal, is it? All right, so one of the first jobs for you as the teacher is to get it in their student mind that the story problems aren't really that big a deal. How many of you dislike story problems? Anna's going to raise her hand. Okay, so what we have to do is we have to hit the problem solving straight on. Maybe even do a motivational idea called Story Problem of the Day, and have it up on the blackboard for your students to solve during lunchtime or during seat work time, or have it up on the bulletin board so that they are not so afraid and paranoid of story problems. Math students seem to have fraction phobia and story problem panic, okay? And so this is something that we need to keep working on, and working on. All right, so story problems is what you'll be doing when you do your homework here. Chapter 6, 6.1 is not assigned, only 6.2 in the chapter review. So the chapter review and test is going to give you enough practice on some of these other expenses. Because we do want to start preparing our students to be able to do percent math. All right, so then in junior high and a little bit in 6th grade, they will do percent applications. and not very much in 5th grade, but in 6th grade, definitely 7th and 8th grade will have an entire chapter, just like your book has an entire chapter on percent applications or business applications, because most of our business things involve percent math. So we don't want to ignore the story problems and so forth. And it is always helpful to show students how they will be using their math skills, and percents is a big part of that. Now I want you to take a look at 6.2, percent of increase and decrease. Percent of increase and decrease is a quirk on finding percents. In our basic percent problem, let's say I have 45 is what percent of 72. This just is very simple. 45 equals 72 times, we'll use a p, and then I'm just going to divide through by 72. Remember, here's our first method for solving percents is algebra. Translate this as an algebraic equation, and it's going to tell you that p is equal to 45 72nds, right? Which reduces to 5/8. Do you recognize 5/8? What is it? 62.5%. 5/8 is 0.625, so it's going to be 62.5 or 62.5%. Basic percent problems. Remember, we can solve it with an equation. But now if we go to percent of increase, it is not just a straightforward percent. This number is what percent of that number. This is a percent problem. Percent of increase is not. Percent of increase is an application problem where, let's say, you can see we've got examples here. It says the wholesale price of coffee increased from $2 a pound to $3 per pound. So it was $2 per pound, and now it's $3 per pound. Percent of increase is not just 2 is what percent of 3. Notice the book starts out here with some nice even numbers. It's not saying 2 is what percent of 3, it's saying find the percent of increase. If it was 2, now it's 3. So it is not saying 2 is what percent of 3. It's saying that find the percent of increase. How much did it increase? It increased, not first, it increased $1. So the actual problem here is $1 is what percent of $2? Find the percent of increase from $2 to $3 a pound. So this is a special circumstance, and so we have to teach it. It's finding the actual increase. I have to find the actual increase. Compare it to the original amount. So my comparison isn't just going to be is over of or percentage over whole. Percent here is just a simple equation. This is not an equation. 2 is what percent of 3? It's asking for the percent of increase. All right, so we had a $2 per pound price. Now we have a $3 per pound price. What was the percent increase? It increased 50%. And when you think about that, it's confusing. But it is a 50% increase. The actual increase was $1. The original price was $2. The $3 just tells us how much it increased to. We have to subtract. So we have to teach them that the comparison that we make now is not 2 to 3, but the actual increase over the original amount. We're finding the percent of increase. Okay, this is a common thing in 6th grade and 7th grade math, not done by 5th graders. Percent of increase. Okay? So we have to teach the comparison. It's not asking for a percent, it's asking for the percent of increase. In this case, it is 1/2, which is an easy percent, 50% increase. Okay, so we have to pay attention to wording on story problems. Find the percent of increase. Actual over original. And then the story problems will always be worded differently. Sometimes they will give you the increase directly. They'll say it increased by $1, and other times they'll give you the new price. So if you look at the application problems to finding percent of increase on page 245, sometimes they give you the increase, sometimes that you have to find it yourself. They might say that the original price, get rid of this problem, we're done with it, might say that the original price of coffee was $2 per pound. We're increasing it by $1. In this case, they're giving you the actual increase. So the wording can be different. So we can't go on what students like to do, and that's autopilot. Have a formula, you have two numbers in the problem, and you just put a number in a slot without thinking about it. Can't do that. So when we're finding percent of increase, we have to pay attention to what we're given. Here's the original price. They might tell you how much they're increasing it, or they might give you what they increased it to. Either way, we have to find the actual increase and divide it by the original amount. The answer here is not 66 2/3%. It's 50%. So we have to watch the wording, and we have to teach the students that the comparison is different. It's not just take the two numbers and put them in a fraction and go through the motions of solving. We have to figure out what we're given. So we have to do the actual increase over the original amount. And many times in the 7th grade book, they start out giving them this combination, and then they progress to this combination. And there'll be some students that pay no attention to the words. They'll just take whichever two numbers are given and plug it in. Doesn't work that way. We have to think through the story problem. And we have to use the actual amount that was increased over the original amount, irregardless of how they express the problem. Most of these, they're going to make you find your own increase, and you're going to want to use your calculator, okay? Because we've got some odd numbers. And notice the directions tell you to round the percent to the nearest 1/10 of a percent. So the calculator is going to give you all kinds of digits. Move it properly and express your answer to the nearest 1/10 of a percent. All right, then finding percent of decrease is actually the same process. And many textbooks will call this, instead of calling it the percent of increase and the percent of decrease, they'll simply call it percent change. Because actually, it doesn't matter which way it changed. So can you find percent change? And to do this, we will always find the actual amount of change. Well, it doesn't matter if it's an increase or a decrease, and we must always do our comparison to the original amount. So we have to think through, if I can make that neater. We have to think through the given problem, not just blindly plug numbers into my little formula here. Actual change over the original amount. It doesn't even matter if it's an increase or a decrease. A couple examples. You'll notice that 6.2 is divided into 4 sections. A, B, C, and D. Section A is percent increase. Section B is applying it. Then section C is percent decrease. And then section D is applying that. So let's take a look at section C, percent decrease. It has the same idea. I have to find the actual change, in this case a decrease, over the original amount. So, example 5, during an 8-year period, the population of Baltimore, Maryland decreased from 736,000 to 646,000. Find the percent decrease to the nearest tenth. All right. This is a decrease, and it tells us that our original population was 736,000, but it decreased to 646. So this is a percent decrease, not a percent one of the other. You can see the actual amount of decrease from 736 to 646 is 90,000. So we have to find the actual over the original, and obviously we can always reduce anything that's in fraction form. Can reduce it down to 45. 2 goes into 7, 3, 6, 8. Does that reduce any more? No. 6 and 8 is 14 plus 3 is 17. Then we can do the division. 45 divided by 368 is, I'm going to look, and then our answer is 12.2% decrease. This is a 12.2% decrease. So it doesn't matter, we can teach these at the same time. It is percent change. And actually it's a good idea to do them together, because that will help you to stress actual change over original amount. We're not going by which number's bigger. Sometimes students will just go by the size of the number instead of what the number really means. So I want to do these at the same time and mix them up. Percent increase, percent decrease. Because the crux of the lesson is to get them to find the actual change over the original amount, not just always subtracting and putting the smaller number over the larger number or whatever. So in this case, we are going over the larger number. In the last case, we went over the smaller number. We don't go by smaller or not larger. We think through the problem. We find the actual, in this case, decrease, but the actual change over the original amount. So we can go back and forth between percent increase and percent decrease. And I do want you to use a calculator, because you can see we've got a lot of messy math. Example 2, Chris Carley was earning $13.50 an hour as a nursing assistant before receiving a 10% increase in pay. What is Chris's new hourly pay? Percent increase can also be used in finding the new wage and so forth. So we need to address this as well. Here's our basic percent change problem, but then we're going to take these things further and apply them to real life situations. I'm not finding a percent here, am I? So let's now apply this in different ways. Most of the time in a junior high and 6th grade setting, each one of these things will be a separate lesson. Here I'm throwing it all to you at the same time. This problem here, example 2 on page 240, we're not finding the percent, we are using the percent of increase instead of finding the percent of increase. So some textbooks will present this as a more than and less than percent problem. So now instead of earning $13.50 an hour, he's going to earn 10% more than that. So now the easiest way to do this is to find 110% of $13.50. What did the book do? Take a look at page 240. What did they do? First they found 10% of $13.50, which is $1.35, and then they added it. Well, you can add before or after. So if he's earning 10% more, that means his wage is going to be 110% Or we can do it 10% and then add it. We can do it separately. We can find the actual increase and then add it, or we can do it all at once. His new pays is now going to be 110% of his old pay. What happens when we find 110% of $13.50? We are going to get our 135 right here. Well, we won't get the zero there. We're going to get the same amount in one calculator punch in. So when things are increased by a percent, we can always add to 100% first and do one computation. Or we can find it and add it separately. This is called a more than percent. Another application of this is sales tax. Let's say I go down to Jewel and I buy, I don't know what I'm buying. Maybe I'm going to buy a roast to put in the crock pot. What am I going to pay for this? Well, it's food. Let's say I'm going over to someplace else. I'm going to go to the Lighthouse Mall and buy a pair of shoes. And of course, the price is not going to be $25. What are they going to have it as? $24.99, right? What am I going to pay for it? Well, Indiana has 7% sales tax. So my actual price is going to end up being 107% of $24.99. Or I can do the 7% separately. 7 times 9 is 63, 34, 15. So that's going to be $1.75 in tax, right? What would happen if I did $24.99 times 1.07? It's going to give me the addition right there on the spot. Of course, I have to round to the nearest cent. It's going to be $26.74. Here, I'm going to still get my 17493, but then 2 slots later, I'm going to get my $24.99, and I will get the same thing. A 7, carry another 1, and I will still get $26.74. You see how this works? How I can add the 100% before the multiplication, and the addition gets built into the partial product, right? This is a more than in percent. And so when I increase something by a certain percent, I can always add to 100% first, whether it's just an increase or if it's adding sales tax. Okay, so you can add to 100% when it's a more than just do one multiplication. You see how I'm getting the same answer? I can multiply by the 7 and add it to the 100%, or I can just say, oh, that's 107%. Okay? Though you do have to be careful with when you have discount and then sales tax. Okay, so there's all kinds of things to go through here with percent applications. And of course, the main application that we have to pay attention to is on objective B. Percent increase in business is called markup. Whenever a store purchases things that they will be selling, they have to mark the price up. So they can make a profit, yes, but also so they have money to pay for what's called overhead. When you own a store, you have to always take your inventory, the cost of your inventory, and you always have to mark up your prices. You have to pay your utilities, you have to pay the rent on your building, you have to pay your employees, you have to pay all kinds of things. That's called overhead. So markup is a part of life. And as a business owner, you have to mark things up at least 40% or more, maybe in 50 or 60% of what you paid for it, in order to be able to keep your store afloat, keep the lights on, keep your employees happy, and so forth. So markup is a direct application of percent of increase. You can see on page 241, the manager of a sporting goods store determines that a markup rate of 36% is necessary to make a profit. What is the markup on a pair of skis that cost the store $225? Obviously, he cannot sell the skis for the same price he purchased them for. He's going to mark it up by 36%, which is $81. So he's going to sell it for over $300 just so that he can make a profit. He'd have to mark it up by, you can see the answer here is that he's going to mark it up by $81, meaning he's going to sell it for $306. That's an application of percent increase. You might even be asked to find the percent increase if you were given this problem a different way. The skis cost $225. We're going to sell them for $306. What was the percent increase, or what is the rate of markup? So markup is another type of percent problem that is related to percent of increase. So what I want you guys to do is I want you to do the chapter review 4, 6, and the chapter test. If you look at the assignment, you're going to be doing chapter 5 review and test, chapter 6 review and test, and 6.2. So 6.2 is the most important section here in the percent application. And percent application is very important. Okay, this is not due Tuesday, I think it's due next Friday. All right, so we will also have a percent application quiz due on Friday, where I'm testing your math skills. All right, so this is probably something that should still be familiar to you. I can tell most of you your math skills are up to par pretty much by how you're doing on your homework and your quizzes and so forth. So let's talk about teaching percents a little bit here. How would you teach chapter 6 to 7th graders? Certainly not in the little brief run through that I just did for you guys. Okay? So what I want to talk about here is going back to our teaching progression. Terminology. Facts. If we were teaching here, let's go ahead. And to relate this to what we've been doing. Here they are. So percent application is down here. So that means it's at the bottom of our list, but really it should, as far as priority goes, we're going to get to it kind of last in our progression, but it should be our goal. Our goal then is, if we're teaching them percent math, our goal then is that they can apply it and be problem solvers. Right, but this is not going to come off very well if we're missing things in between. So in the case of our textbook here, chapter 5 teaches percents. And hopefully we've mastered basic percents. We have to have procedure down already with our percents. Otherwise, application is going to fail miserably. Application is going to show that they don't understand something. So we have to have both of these down. And what? Application is going to show if we understood concept. But it is not only just dependent on understanding concept and having procedures down. So we have to understand the concept, and have the procedures mastered. Or at least down pat for right now. Otherwise, we're going to fail miserably when we get to chapter 6. Okay? And so, it's kind of funny in the 7th grade math book, it's chapter 5 and 6 as well. And so what we have to do then is make sure that we've done our job so that we can get to our goal of being able to solve problems. We want our students to be able to think and be problem solvers, not just be able to do simple percent problems, okay, like solving puzzles. All right, so we do have to also come back to terminology. I find a lot of times that 7th graders, I don't know if they apparently don't live in the real world, but some of them don't really understand about sales tax, other than the fact that, well, the sales tax is not so much a problem. But I'm kind of always amazed that some of the students don't have any idea about discounts and things being on sale and how that affects price. And they can't think through a simple story problem because they don't have experience buying things at the store because they're not adults. So we have to go back through and pick up on our terminology. What is sales tax? What is discount? What does it mean when something's on sale? And we have to take the terminology and relate it to the students. You would think that by the time they're in 7th grade, they should be able to add sales tax to a purchased item. But I find a lot of them don't know what to do with the sales tax. Some of them would even subtract it. It's like, you're going to get fired if you start work. Good thing you're not programming the computer down at the store, because you have to add sales tax. And they'd be confused. When do I subtract? When do I add? Well, that's because they're not thinking it through what's going on. They've decided that the story problems are too hard and that they're not going to be able to figure them out. So we do have to relate our new terminology to our students as far as what is sales tax, and get to relate that to their life. They've all bought stuff at the store, and they've all, I don't know, if it ever happened to you, especially as a child, when you had your $10 that you were spending for your birthday and you found something was $9.99, you had to be really good at getting some change from one of your parents to cover the sales tax, right? Or ever gone and not have enough money because the sales tax put you a few cents over or whatever. Embarrassing. That's why I use a debit card, right? So I don't have to worry about sales tax. But anyways, we have to relate it to the students and make it interesting and make it fun, and even use it for some type of motivational idea. You're going to have to do a percent theme folder. So you can do a lot with percents and making it as a motivational idea, dealing with actual things that they're going to use. We're going to use our percents to find sales tax. We're going to use our percent to look at the store and see if that's a good sale. Or I want to buy that pair of shoes and it's 20% off. What's the new price? And so forth. And most women, at least, are really good at discounts and estimating prices and so forth because they shop a lot. Students don't shop, apparently. Okay? Our students don't have money to spend, and so they are somewhat clueless with respect to discount and sales tax and so forth. So you can't assume that they know the terminology. You can't assume that they are used to working with sales tax like you would be. And they're used to finding discounts like you are. So terminology is important. You have to relate it to the students, and you have to put the circumstances in context. And when you do that, you have to remember that they do not have the context. They don't do the grocery shopping. They don't buy things that often. All right, and so, and many of the times their parents are doing all of that for them. So they are clueless about discount and sales tax. And most certainly they would be very clueless with respect to commission, wouldn't they? Okay, they don't know what it is. They don't even really, a lot of them would have no context. They don't know anybody who's a salesman. They don't, unless their father is, then maybe they'd be familiar with it. But they have no idea about commission. They have no idea about discount and sales tax. So we do want to start with discount, sales tax, and so forth, because we've got to relate it and put it in context. And we've got to keep making them stop and think. Okay, when you go to the store and you buy something that's $9.99, $10 will not be enough. Why? Because they always add sales tax. Okay, and then I always have students that then subtract the sales tax. And it doesn't make any sense to me. It's like, you can't subtract the sales tax. Sales tax, think. When you go to the store and they ring up your purchase, the cash register does not take off 5% or 7%, or in the city of Chicago, I don't know, it's probably getting close to 10% sales tax, because you've got state of Illinois, you've got Cook County, and then you have city tax and all kinds of stuff. Okay, so we have to relate it. Facts, if we know our percent, fraction, decimal, I'll just write it out, fraction, decimal, and then percent equivalents, and we're drilling them still, that's going to help them so that they don't have to spend all that time actually finding easy percents. But then, so there's all kinds of things that involved here with application. We have to put our terminology in context and relate it to them so that they're not doing odd things with their discount and odd things with their sales tax. And then if they already know their facts, then that's something we just don't have to deal with and worry about. We can concentrate on the application. Hopefully we've taken care of the problem areas and so forth. We've got this down pat. The procedure is down pat. The procedure is more familiar, so then we can do application. If we try to do application ahead of time, it's going to be a disaster. But at the same time, in chapter 5, we should still be doing story problems. We don't want to ignore the story problems during the regular teaching of it, but then we're going to concentrate on it. So we want to be doing application all along, but then we have to make sure we understand the students understand the concept, they've got the procedure down. Otherwise, they're so focused on the math that they don't try to figure out the circumstance of the story problem. So percent applications are a real challenge to students because they're stuck up in here. So we have to keep practicing this, practicing this, practicing this. Okay, so one of the things that we talked about first semester was practice, 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 practice. Math requires a lot of practice, so we have to make sure we have basic percents down in chapter 5 before we try to do chapter 6. But actually chapter 6 here, application is the goal of teaching mathematics, is being able to use the math skills in real life situations, being able to do sales tax, being able to make sure that we know we're able to apply sales tax, we're able to figure interest and stuff in our own finances. So chapter 6, percent applications. We have to work towards them with our other progression. We're working towards them, working towards them. And that doesn't mean that we do them at the end. We should be doing them all along, but there's a special problem with the percent applications. And here's why. We don't have it up here yet, do we? And we're trying to get down here to the application. The application problems for you yourself should be pretty easy because you do live in the real world and you have a little bit of experience with some of these things. The joke sometimes in my class is, do you speak English? Because sometimes it seems like they totally miss, and that goes back what I'm saying. They miss exactly what I'm saying, and it's like I'm speaking a foreign language because they don't know the terminology. They don't know what commission is. All right, and then we start doing all these application problems, and we call some of the same things, we call it sales. We have the sale price, right? And then we have the original price, and we have all these different terminologies. When something's on sale, we're going to pay the sales price. But then when we get to the next section and we're doing commission, we're talking about sales in a different context. We're talking about a salesman's total sales. And it confuses them because we're using the word sale for selling price. We're using it for when something is on sale, find the sale price. Well, wait a minute. I just was finding the selling price with markup, and now you want me to find a sale price? What's the difference? Selling price, sale price. So there's all kinds of confusion that can be done. So we've got to practice these and try to teach our students to stop and think through what's being said. What is the story problem saying? So application, percent application is one of the most challenging things that you will teach as far as arithmetic goes. And a lot of it is because we have to keep going back to this. We have to spend time and make sure that we can do those basic percent problems in our chapter 5. Otherwise, we're going to have a disaster when we get to chapter 6. Percent increase, percent decrease. I have it easy with you guys because you should already have your math skills and your problem solving skills intact. Not the case with 12 and 13-year-olds. So we have to be aware of it and not just go through, well, I know this is easy for me because, you know, I know what sales tax is and I've dealt with it over and over and over again. So we have to go back to don't assume they know anything. Our theme in primary math is that we're teaching from scratch. So in intermediate math, you have to realize that this for them is unfamiliar and you have to go back and teach from scratch, going up and getting them to think, what is a salesman? How do they make their money? Especially in today's business world, I think mostly car salesmen are the only ones people that I really know that earn commission. I'm sure people that sell pharmaceuticals are on commission and so forth. That's why when you walk in the car dealership, you get bombarded, especially if it's coming towards the end of the month and they need to make a certain amount of sales for the month of February or whatever, because they have to earn their commission and the students have no concept of that. So we have to make sure that we teach percent application from scratch, simply because the students do not have the context. They don't have that real world context that you do. All right, so decimal theme folder and be working on your application. And I'm sure none of you forget that I told you to use a calculator in chapter 6. And I do let the 7th graders use a calculator. And they think that it's going to be easy because they have to use the calculator. And they're real surprised that you have to know what numbers to put into the calculator in what order. So go ahead and use calculator on the application parts. We'll see you on Tuesday.